All right. So 4x. Going to have to factor out the 4. And that'll cause plenty of problems, right? Have to deal with a fraction. Dang old 1/2. So hopefully some of y'all quit, right? Did you quit?
Yeah.
Good. Get y'all to quit this class before it's over with. All right, give it to me. 4 what? 4x squared?
Minus 4x.
4x squared minus 4x
Minus 3.
minus 3 is equal to 0. 4x squared minus 4x plus blank is equal to 3 plus blank. Factor out a 4. X squared minus x plus blank is equal to 3 plus 4 times blank. What's half of 1? 1/2. 1/2 squared is? I heard somebody say 0.5. Why do you not use decimals? Because then you have to depend on what? Calculator. Whole purpose for using fractions is so you can revert back to your 3rd, 4th grade mathematics that you didn't learn. Right? 4. Shortcut number 2. What's 3 plus 1? Y'all might want to check that in your calculator.
You gotta square that little parenthesis thing,
What parenthesis thing?
like in your last step.
Yeah, that's my.
Oh, sorry. Thank you, Miss Anthony.
You're welcome. See, I can be helpful.
10% of the time, right?
Yeah.
All right, so here, that part right there, I will try to copy, and it will not copy, but I'm going to try it anyway. See? Well, forget it. So at this point, you can go 3 different ways. You can do f of x is equal to 4 times x minus 1/2 quantity squared minus 4. And at that point, you know that the vertex is 1/2 comma negative 4. Or you can just write it out as the opposite of both, 1/2 and negative 4. Or we can go solve it. So I'm going to go over here and I'm going to rewrite it. 4 times x minus 1/2 quantity squared is equal to 4 divided by 4. X minus 1/2 quantity squared is equal to 1. Oh, this one's difficult. What's 1 minus 1/2? 1/2, Hubert. Thank you, class. And what's negative 1 minus 1/2? Negative 3/2? Yes, Hubert. No, Hubert. Thank you, class. So, we've got a y-intercept of negative 3. We've got a vertex of 1/2 and negative 4. We've got a intercept of 1/2 and negative 3/2. Something don't look right.
Aren't we supposed to move the 1/2 over to the right side?
Yeah, it's like
Yeah, because you did. You did
It's
move the
positive
1/2 over, so
1/2.
it's positive 1/2.
Okay, we got 1/2 all over the place. You got to tell me where you're talking about.
Like where your circles are. Like,
Right here?
no, like
Far
over,
right.
right there, yeah. And that equation to the right of it, yeah, you got to move that 1/2 over instead of just saying it's a negative 1/2, because then it will
Yeah.
be positive.
What's 1 plus 1/2? 3/2.
Yeah.
There we go. And 1 minus the negative be a negative. There we go. That looks better. Now, I did that on purpose because what told me something was wrong?
The graph.
The graph. You've got to sketch it. I don't care if it doesn't say, if the directions doesn't say graph. Graph it, because I just found an error and I didn't even finish the problem. Okay? I mean, I finished the problem, but I found the error when I did the sketch. Okay, so 3/2, that looks better. 3/2 is 1.5. So, and negative 1/2. Why is it so skinny?
Because the 4.
Good, the
8
4.
is the biggest.
And we're going to go over that. Well, you know that from college algebra. 4 makes it skinny. Domain, all real numbers. Range is -4 to infinity. Decreasing values from negative infinity to 1/2. Increasing values from 1/2 to positive infinity. Line of symmetry, x is equal to 1/2. And you should know all of that. If you don't, then consider yourself a failure. All right. So let's move on to logarithms. Now, in algebra, there's 2 sets of rules that are very similar. Okay. One is the exponential rules. The exponential rules are a to the n times a to the m is equal to a to the n plus m, and that's your product rule. I probably have already went over these. I don't know, because I got a college algebra class, so I don't know if I went over them for y'all and them too. I can't remember. A to the n divided by a to the m is equal to a to the n minus m, which is your quotient rule. A to the n raised to the m power is equal to a to the n times m, which is your product rule. A to the negative n over 1 is equal to 1 over a to the n, which is equal to your inverse rule. And a to the n over a to the m raised to the negative w power is equal to a to the m over a to the n. Flip what's inside and the w becomes positive. That's your inverse power rule. And you should all remember those from college algebra. Your logarithmic rules there's quite a bit of them. What is logs? Logs are basically an exponent on steroids or exponent on vitamins. Okay? Basically, that's what they are. The definition of a logarithm is one of your most important rules. And that's where you have y is equal to log base b of x. Draw your little yield symbol there. And that's going to be equal to a to the y is equal to x. I'm sorry, b to the y. Sometimes they put a, sometimes they put b. b to the y is equal to x. That's the definition of a logarithm. In other words, if you have something written like this, you can write it as an exponent. You also have the change base formula, or we'll go through the product rule. Log of x plus the log of b, or log of y, is equal to the log of x, y. And that is your product rule. Log of x minus log of y is equal to the log of what? X over y. What do you think that's called? Quotient rule. Log of x to the n power is equal to n log of x. What do you think that's called? What is it dealing with? What moves? Huh?
Exponent.
The exponent. What else is an exponent called? Power. So what do you think it's called?
The power.
Power rule. I can't get much by y'all. You're new, aren't you?
Yes, sir.
You just wasn't here the other day.
Yes, sir.
You were absent. I dropped you. Sorry. You can leave. I'm kidding. Was you here the first day?
Yes, sir.
Okay. Now, there's a couple of other ones that you need to be aware of. The change base formula. Let's see if I can do this. I doubt it'll let me, but well, I'll be done. The only problem is it's way down there. How can no pattern whatsoever? All right, another one is the change base formula. Log base b of x is equal to the log of x over the log of b. That's the change base formula. Now there are a few assumptions, there are a few properties that you need to be aware of. If you have log base 10, that's equal to just log. That's why you hear teachers say log. That means log base 10. If you have log base e, somebody tell me what that is. Good. Log base e is equal to natural log. Now, the reason I tell you that is because some people, like me, I like to deal with log. It's just a preference. All right? If you like to deal with log and you're given an ln problem, you just change ln into log base what? E. And you can, these are the same rules with log and natural log. Natural log of x plus the natural log of y is equal to the natural log of xy. It's the same thing. Okay? I believe somebody is doing this. I think Miss Anthony is doing it. Okay? There's also some properties like the natural log of 1. You can't take the natural log of a negative number. And just so I don't miss any, that's what's so great about the internet. I love movies, and whenever I'm watching a movie, I'll Google stuff all the time, like words that I don't know the meaning of. You ever watch Brother, Where Art Thou? Dang old George Clooney uses words I've never heard of before, so I have to look them up. So, anyway, go to Google. But some of y'all probably know all the words in the English language, so more power to you. I don't. So I Google stuff. So pull up dang old properties of logs. Dang old images. Look at there. Isn't the internet great? And the one I want you to look at is these first three right here. Like I said, I need a banner. I'm tired of doing this. Let's see, where is it? Here it is. Log base A of 1 is equal to 0. I just want to make sure I had them all written down. Log base A of A is equal to 1. And log base A of A to the x is equal to x. Now you're going to see this one right here in calculus a good bit. And you're going to see it in diffie-q. Log base A of A. If the A and the A are the same, in other words, log base 10 of 10 to the 5th is equal to 5. If the base is the same as the number beside the log, then it's equal to the exponent. You're going to see that in diffie-q a good bit. And all those other ones is ones that I showed you. The reason and you can Google them, and when you Google them, you get the whole shindig. No matter where you pull them up, you get the same thing. Here it shows the natural logs also, which is the same. Log base 10 of 10 to the x is equal to x. That's the definition of a logarithm. And you can pull up the definition of a logarithm if they don't show it to you. I don't see it, so just pull up definition. Y is equal to log base b of x. B to the y is equal to x. That should be what I wrote. Okay? Now, how do you use them? Well, that's the discouraging part. The easy part is, looking at them. The hard part is doing them. So, hopefully I can lose some of y'all while we're doing logarithms. All right. Huh?
You've already lost me.
Okay, good. Let's go to the handy-dandy log homework and see if I can find some difficult ones to discourage you. Come on. All right, ladies. Here we go. Okay, let's just start with an easy one so I can get your hopes up. 5 log base b of u minus 8 log base b of v. There it is right there. Let's see if I can use the tool. At least it'll work. Look, handy dandy whiteboard. Wherever it went. What I pulled up? That ain't what I pulled up. Really? Try it again. Sorry. There we go. So, what can we do first? Just sit there and stare at it? Throw your pencil down, make it pop against the notebook? Y'all ain't never done that before, have you? I'm just going to quit and change my major to underwater firefighting. Well, that 5 is out front. What can we do with that 5? Move it to the up there. So, using what rule? Power rule, Hubert. That's right, class. Thank you. Okay, that's using the power rule. Now what? The what? Dadgum, this Anthony's on a ball today. Of u to the 5th, what? V to the 8th. And you're done. That's it.
How do you know when you're done, though?
Because there's not really anything else you can do. A lot of people say, well, you can use the change-based formula. The change-based formula is only used when you can't take the log of something on the calculator. You need to write that down. I forgot to tell you that. Okay? The change-based formula is only used. I'll show you how to use the change-based formula. Take the calculators out. Log base 2 of 5. You can't do that on a calculator. Why? Even though some of y'all believe a calculator can drive your car and walk on water, your calculator cannot do everything. Okay? The calculator only thinks in terms of log base 10 and log base e. So, you can't do log base 2 of 5. Even a la calculator cannot do log base 2 of 5. So you have to think and change it into log base 10 of log base 10 of 5 over log base 10 of 2 or log of 5 over log of 2. And then you can put it in the calculator. So you can only use the change, well, unless the directions say use the change-based formula to change it into another form. But most of the time, the change-based formula is used when it's calculated. So, Miss Anthony, to answer your question, Is there anything else you can do to this? Well, look at your other rules. I mean, there's no other rule to fit. You use the power rule, then you use the quotient rule. That leaves what? The product rule? Well, you don't have anything to do the product rule with. Power rule, there's nothing in front of you. You already used the power rule. So really you just go down the list and see if there's anything else you can do.
You said the change-based formula can only be done, can't be done in code. Right?
You could do it with this, but the directions would say use the change-based formula to change the form of this. It'd be a mess. You'd have log of all of this over log of b. That's what you'd have. But there's no sense in doing it because you can't take you can't calculate the log of this because you don't know what u and b is. So there's no use in using the change-based formula. The only reason they would say use the change-based formula is if they wanted to change the form of that. So hopefully you're discouraged there. Let's see what the answer is. Take our handy-dandy homework. I have no idea how to type it in, but we'll just type it in. I don't forget what it was. Log base b. So does this thing have a...
Can you go to functions?
Thank you. Log.
Bottom right.
Oh my God.
No, the one, that one.
This one?
Yeah.
Log base b. I guess we'll have to type in a handy-dandy fraction. Dang old u to the fifth.
Yeah.
So that'd be u shift to the fifth. Shift 6 is caret symbol. Over v to the 8th. Shift 6, 8. What do you do? Hit submit answer. And you have to wait a couple hours. Look, we got a little green check. I'd love to be able to program stuff into these things. You suck if you get it wrong. Put a big old X across the whole screen. But you suck. You are a loser. You should quit school. An engineer? Question mark. Try underwater firefighting. Try parks and recreations. I would get so fired the first day if I was a programmer. Yes, sir.
How many attempts do we have on each question?
I'll have to go in and look. Since I just started this homework, I don't know what I set them as, but I think you can try them as many times as you want to. I'm not one of those that program it to 3 times, and if you get it wrong 3 times, it marks it wrong and you can't go back and do it. I'm not one of those. I believe the more times you do it, the what? The better you are. Any questions?
What
All
are
right.
logs used for?
Say again, what?
What are logs used for?
Logs are used mostly when you're calculating a lot of exponential growth. Bacteria. A lot of scientists use logarithms. Scientists, any of your scientific research, carbon dating, anything having to do with bacteria growth. Of course, your physicists use it like crazy. Engineers use it, but it's based on strength. A lot of strength of materials when you're calculating a lot of strength on a tensile strength of a beam or whatever. You use logarithms. Logarithmic graphs is used a lot in logarithms. I remember civil engineering, we had to use logarithmic graph paper. But that's been so long ago, and I didn't care about civil engineering, so I can't remember what it was. But I remember having to use logarithmic graph paper. So it might have been in physics. When you're a civil engineer, when I was a civil engineer, you had to take 3 physics. And I remember using, either in civil engineering or physics 3, you had to use logarithmic graph paper because everything that you did was done on a logarithmic scale. and logarithm is an exponent on vitamins. So you have to make exceptions. But a lot of scientific growth, carbon dating, and anything having to do with growth beyond the exponential scale. And if you graph a logarithm, no, y'all in class. If you graph a logarithm, you'll see the difference between exponential growth and logarithmic growth. You'll see the difference. It's more steep. And the decay is much more steep. So it's just I guess you'd call it an ant of logarithm, exponents. So, question. All right, let's do a nerd. I want y'all to do, let's do number 3. Right there. What? What y'all laughing at? Y'all laughing at me. We didn't do number 2, did we? No. We're going to do number 3. Yeah, I'm going to do your homework for you.
It's fine by me.
Yeah, y'all still get it wrong even if I did it for you.
Probably.
You know why? Because y'all are failures. The sooner that y'all realize that, the better you are. I'll use my little handy dandy tool I don't like to call out. Why can't they use it? Can't they use it? It's like copy and paste tool. Why do they call it snipping tool? So, now, I don't know if you've had me before, but one thing that I do whenever something looks confunctious, when something looks like it's a mess, I kind of break it up. So the first thing I'm going to do is